Hello everyone and welcome to my YouTube channel. Welcome to this new tutorial of Plaxis. So if you're into civil engineering and love to learn, just subscribe to my YouTube channel. It will be a great help. So in this tutorial, I'll be talking about a road embankment. So in my tutorial in general, I uh, I don't only solve the tutorial and tell you how to draw it in Plaxis because it's very easy to do it by yourself. I always leave the PDF, you can download it and learn it by yourself. But I love to explain and tell you how Plaxis work and how geotechnical problem work. So that's why I do the tutorials. So let's start. The problem consists of a road embankment. The consolidation of an embankment on a soft soil with high ground level leads to an increase in pore pressure. So when the soil is not uh, consolidated and you assign a pressure to it, there will be a great pressure in the soil. So the purpose of this tutorial is to show us how to create a road embankment by consolidation of the soil by levels. So first of all, you're gonna put half of the embankment and leave it for 30 days in order for the water to leave the soil. When the water leaves the soil, there will be less pore pressure from the water. Um, there will be a deformation in the soil, and then the soil can take much more pressure. So in this tutorial, we'll be learning to do drains, consolidation analysis, change of permeability during consolidation, and safety analysis. So let's start. First of all, we're gonna draw the geometry. Here are the geometry. You can draw it from here. Then we're gonna draw the soil layer. From here you can take the properties. And then we're gonna go to the structure. So to save some times, I made the materials and I've drawn also the borehole. 0 minus 3, minus 3 minus 6, and minus 6 minus 10. The head is minus 1. So now we're gonna go to the structure. So first of all, we draw this project with y equals 2 meter. It's in order to put a drain, because we put a drain each 2 meter in this tutorial. We made a drain each 2 meter. So that's why we are studying the embankment in 2 meter and not at 1 meter. So if there were no drains, we could have modeled it in 1 meter. So let's start first of all by creating a surface, and then we're gonna create a line. Then we're gonna extrude the surface and the line to create our soil volume. So let's start. We're gonna first of all go to surface, create a surface. We're gonna assign 4 points. We're gonna change the coordinates to 0, 0, 0. Here. So there's multiple way of drawing Plaxis. I usually draw this way, but I show you also multiple way in different tutorials. So this is the embankment. We're gonna press on OK. Then we're gonna draw a line. I'm gonna change the coordinates to 0, 0, 2, and 14, 0, and 2. So this is the line. Okay, so the coordinates are right. Can I draw the plate? Just check if the coordinates are right here. Okay, so now the coordinates are right. We can see the line is passing through the embankment. So there's another point here that we have drawn half of our embankment because it's symmetrical and there's no need to draw the whole embankment. So whenever you can save some time in Plaxis, just do it. It's better. So now we're gonna extrude it to 2 here. Apply. So now we've created a volume and a surface. So now we're gonna delete the surface and the line. We're gonna right click on the volume and assign it to soil level 4. So let's start by doing this. I've deleted the surface, this is the line. So there's the embankment and there's the surface here. I'm gonna press the soil and create soil set material. I'm gonna set the material to embankment. Okay, so now we're gonna draw the drains. So what is a drain? When we consolidate the clay, when we put a load on the clay in order for it to pass through a consolidation, we can put some drains to have a faster consolidation because the water, when the excess water pressure will escape the soil, it will go through the drains and it will be taken off sites. So first of all, I'm gonna click here to create a line drain. So the coordinates are 1, 1, 0 and 1, 1, minus 6. So this is the drain. Now we're gonna create an array of this drain by applying this array here. So this is x direction, number of column 10 and 2. So we've created all our drains. Let's see if we're forgetting anything. Okay, so we set the material to embankment. Okay, so now we're gonna generate the mesh and we're gonna set the coarseness of the embankment to 0.3, then create the mesh. Go to mesh, we choose the embankment, I'm gonna create the coarseness factor to 0.3. Is there anything else? I'm gonna generate the chord. Okay, so this is it. So this is our mesh. So now we divided the soil by 2 in order to put the first load. It will be this embankment. We'll do a consolidation for 30 days. Then we're gonna put this one. Flow condition, we're gonna leave it. For heads -1. So now gonna go to perform a calculation. We're gonna do 2 calculation of this embankment. The first one without drains, and the second one with drains. So the initial phase, we're gonna leave it to K0 procedure to generate the stress, the initial stress in the soil. Pressure is hydrostatic based on a phreatic level head for initial phase. Okay, and we're gonna change the boundaries also for the model. Let's start. Okay, it's done here, and we're gonna change the boundaries. We're gonna go to here and set them like this. We're gonna go to model condition, boundaries. Okay, so I'm gonna explain why they are closed, open, closed, closed, and open, open. So in X minus, it's here, it's closed because it's symmetrical. We have another embankment here. And this way, the water can escape from here. And in the Y direction, we're gonna take it as closed because there is also an embankment here and an embankment here, so the water can't escape for here and here. In the Z direction, it can escape upwards and downwards. There's no problem. So this is the ground flow condition. Okay, so we're gonna start the consolidation analysis. First of all, we're gonna introduce the dimensions of the time and calculation. Okay, loading type parameter, consolidate and predefine the period. Consolidate until excess pore pressure and the geometry have reduced a predefined minimum value. Okay, so here there's plenty of load type in Plaxis. I'm gonna explain them. When we do a consolidation here, we can choose the staged construction. So we consolidate our soil until we have a construction on the soil, or until minimum excess pore pressure when all the pore pressure leaves the soil, or a degree of consolidation. We choose this degree. So this is the difference between these 3 options. So we're gonna start by drawing this one here. Okay, so we added the volume here. I choose it to consolidation, stage construction. Here I'm gonna leave it phreatic. I'm gonna put a value of 2 days here. Okay, so now I'm gonna activate the first part of the embankment. Okay, so now I'm gonna create the second phase. In the second phase, there's no changes in geometry, only a consolidation analysis that ultimate the time is required. We're gonna add the calculation here and specify it to 30 days. Okay, add. It's from phase 1 here. Consolidation, I'm gonna leave it to what was the value here. I'm gonna leave it to stage construction and choose 30 days. Okay, so I'm gonna create the phase 3. What is phase 3? Phase 3, we're gonna add a phase, consolidation, specify a value of 1 day, and activate the second part of the embankment. So this is 1 day, consolidation, stage construction. Okay, in this part I'm gonna turn on activate. Then I'm gonna create the fourth phase. In the fourth phase, we're gonna do a consolidation analysis also. Gonna select minimum excess pore pressure in order to have all the pore pressure eliminated from the soil. Gonna leave this value here, and we're gonna press on OK. If you see the estimated time here, we can't change it anymore. So now we're gonna start the calculation, but before we're gonna specify a node. I'm gonna go to here and specify the second point. The first point is 20, 0, 0. Search closest. Okay, so I can change this tab here because my window is small. So I'm gonna choose it manually from here. I'm gonna update it and launch the calculation. Okay, so I'm gonna pause here to finish the calculation. Okay, so I restarted the recording here just to show you how much time it can take to calculate all these phases. So it's been, I think, half an hour for now. So what I've done is I've redrawn the other phases. The difference between the first part and the second part, in the second phases, we've created the drains. We've activated the drains. In the first part, we didn't do it. So there's another type of calculation that we did in this tutorial is the safety analysis. So you can find the details in the PDF. I'll attach it in the comment section. So what we've done here is a safety analysis. So what is a safety analysis? A safety analysis is a feature in Plaxis. So just a second, I'm gonna open the PDF and show you. Okay, so this is a safety analysis. In our case, it is important not only to see if the embankment is stable in its final stage, but also to examine the stability and its construction, the safety of it. So as we can see here, after we put the first load on the embankment, we can see the consolidation here. It's the pore pressure. In the second phase, you can see this graph here. It was near failure and it went back down. So it is important to calculate the safety factor of the embankment. So this is why we've done a safety analysis. You can read this PDF. It gives you a good idea about the safety analysis. So for now, I'm not gonna explain more about it. I'm gonna wait for this final calculation and see a little bit of displacement of our embankment. So there's another point here I like to talk about is the embankment. So the ratio here is 3 to 1. So every 1 meter in the z direction, we go 3 meter in the x direction. In this way, the embankment will stay stable. Generally, when we construct any type of embankment, this ratio is between 1 to 2 and 1 to 3. 1 to 3 is more safe. So I advise you, whenever you have something to do with embankments, like embankments dam, or road embankments, or embankments for river, just go for the factor 1 to 3. If you can, of course. So I'm gonna pause the video to finish all this calculation. Okay, so I'm finally done. We're gonna go a little bit to the output and see the overall stability of the embankment. So first of all, I'm gonna go to phase, say phase 3. Okay, and we're gonna see the displacement. This is the total displacement of the dam, of the embankment. We're gonna take a section here. Say it's 1, 1 and 2, 1. Let's say section. I'm gonna go to phase 8. Okay, and see the formation. You can see the dam at the embankments here, the failure of it. So this is the slope stability of the embankment. We can also draw the graphs here. So this will be all for this tutorial. If you want to do it step by step, you can, following the PDF. I'm gonna stop here. Thank you for watching. I'll be making more videos about it.